Hi, in my last video, I talk about use the manual auto memory to trigger the to dump the kernel and the user space memory usage, and so but the manual OOM would select a process to kill, which is not good in a production box. So I talked about maybe attach the kernel to dump the kernel memory and the user space memory usage without actually killing a process. So for example, I have a virtual machine, a CentOS 7 virtual machine running on my KVM hypervisor. It's a CentOS 7, and let me log into. This is my CentOS 7 virtual machine IP address. Let me log in. So remember, like echo F to proc RQ trigger, it will trigger a manual auto memory execution. So we run the message here. Manual OOM execution. So it will dump all the memory for the Linux system, including each node and each zone for each node, and swap memory usage, and per process memory usage. And this counter is also very interesting for each process. See how many pages the process swapped out to the swap memory partition. But the problem is, if you run this, the auto memory killer will select the process to kill. This is not good on a production Linux box. So and also there is for sysrq. You can also echo M, which is to dump also dump the kernel memory. See show memory, but it does not include the per process memory usage. I think that is important for if you want to see which process on the Linux are using memory or high swap memory, and so this is not good enough. And so I think I wanted to patch this show memory to show the per process memory usage in addition to this, and that could be used for production box without actually killing a process. Yes, so I'll show you what does the code look like. And so I downloaded the CentOS kernel source code and patched it. So this is a source directory. So this is my diff look like, and so this is the original kernel source code. This is my modification. Basically, I removed this function find lock task mm out of the OOM kill.c file, and added it in the kernel source showman.c file. The reason I added this function in the showman.c file is because by the way, the show main is the function that's got a call when you echo letter M to the /proc/sysrq-trigger, and that's this function gets called, and originally they will show the memory info. So I added this like loop through each process and it dumps the memory usage for the process. Okay, so so I patch the kernel, compile the kernel, and I can show you, like if I exit the virtual machine and I get a console access to the virtual machine. So this is a console. If I reboot this virtual machine and select the kernel, the custom kernel I compiled. So this is a stock kernel from the CentOS 7. This is my customized kernel with a patch built in. So I will boot this custom kernel. Let's wait for it to boot up. Okay. So we logged in. So now if I echo M, it should show the per process memory usage. Right? So show memory. And this is a per process memory usage here with a swap entry, right? So we can show them per process memory usage without actually killing a process. And let's generate some swap memory. So this is a test Python script to create some memory load on the virtual machine. So let's do it again. By the way, this test script also triggered the auto memory kernel. So this output, as you can see here, this output is from the auto memory kernel, right? And it shows you the swap pages in the swap partition, including this test py. It has the biggest memory usage in the swap. And so this one though, is my patched kernel to show main, and it also shows the per process memory usage. And you can see here, it also shows the test py with the biggest memory usage in the swap, right? So this is invoked by the OOM kernel, which will actually kill the process. right? So I think this is good to diagnose Linux memory problem and without actually causing downtime. And also, by the way, you can use just regular top command to monitor memory usage like you normally do. And you can also show, if you're interested in swap, you can also toggle the swap here. Yeah, my terminal is a little, yeah, and you can use top to monitor the per process swap or memory usage, but the top doesn't show you the those stuff like those internal memory stuff, and you can get those information from the /proc information. Like you can get those from /proc. Like you can get this from those stuff, like those internal counters, right? Like body info, it's for the orders, for the node, for the zone, for the order 0 pages, 1 pages. But I like the way like all those information are here together, right? So they're all here, and you don't have to look individually into each file, each /proc file, and so yeah, just my opinion. Yeah, hope this is useful for you. Thank you.